turning the head to tail. Head to tail.
Sup, Mr. Sai?
Good morning. What happened?
Through traffic.
Okay. So as I was saying,
Vectors are frequently brought up in physics. When distinguishing vectors from scalars, just always ask yourself if that quantity is accompanied with a direction. If it does, then it is a vector. It's easier to represent vectors as arrows, which consist of a tip or a head and a tail. The vector's magnitude is always equal to the length of its arrow. The direction of a vector is commonly expressed as an angle of rotation of the vector about its tail from east, west, north, or south. Always remember to never change the length or direction of the arrow. Wind is an example of a vector quantity, as it has direction and magnitude, such as 45 miles per hour southeast. Momentum vectors are also useful when you want to predict what will happen when two objects come into contact.
Mr. Sai, how am I supposed to remember this?
there is a really good way to remember this. Bye, okay? Oh my god. Are you ready? You ready? You ready? You ready? Ready? Are you ready?
Yes.
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 You ready? You ready? You ready?
Yes.
Okay.
Because you know I'm all about that vector, no scalar. I'm all about that vector,
No scalar.
I'm all about that vector,
No scalar.
I'm all about that vector.
Yeah, it's pretty clear. I ain't just a line. You find out my components, find that X and Y. Cause I got that magnitude and direction in all the right X's in all the right places.
I see the hairstyle working my head to tail. Did you know you could change it and make it tail to tail?
The point is the tip and the base is the tail. A vector's magnitude is equal to the length of its arrow. Then my teacher, he told me to worry about the length. He says the length and direction always remain the same. You know those vectors can be solved in two very different ways. You can solve algebraically and also with graphs to scale.
Because you know I'm all about that vector, no scalar. I'm all about that vector,
No scalar.
I'm all about that vector,
No scalar.
I'm all about that vector. I'm bringing direction back. Go ahead and tell them scalar quantities way.
Nah, I'm just saying the scalars aren't as cool. But I'm here to tell you that every physics problem always has a vector quantity.
Yeah, my teacher, he told me all the different quantities. He says that they include displacement, acceleration. You know that velocity is also a vector quantity. Momentum and force because they all have direction.
Because you know I'm all about that vector, no scalar.
I'm all about that vector,
No scalar.
I'm all about that vector,
No scalar.
I'm all about that vector, all about that vector,
No scalar.
all about that vector,
No scalar.
all about that vector,
No scalar.